couple more slightly complicated problems. So what rule must be used to differentiate this guy? Chain rule, and I don't think there's any product. Where are you seeing the product? I'm just curious.
Well, it looks like tangent squared is 1, sine x would be 1, and 4x.
But for it to be a product, it would have to have been tangent squared x sine to the 4th x, like that. You see how that's different? So in this case, the sine's inside the tangent is supposed to be multiplied by a tangent with an x in and of its own.
Oh, okay.
You see what I'm saying?
Yeah.
So actually, a big old hint is that products are often going to have, there has to be an x in each function. Does that make sense? Okay, so that would be the product rule. All right, but this one is just like massive, massive chain rule, and you have to keep track of which things you chained and which things you haven't. But you've gotten a lot better at that, so I think you can do it. Okay, so what's the first part you chain? The squared, exactly. So that becomes 2, and the stuff is now to the first, which you could not write, but I'll just write it there just for extra carefulness. So you've done the squared. Who's the next inside function?
What is tan squared?
What is tan squared?
It doesn't have any fancy thing that comes out.
No, tan squared is tangent of all that stuff, the quantity squared.
It doesn't have like another identity hidden.
Oh, you could, yeah, but that wouldn't really help.
No.
Okay, so who do you differentiate next? Tangent, and that's going to be secant squared, and what happens to the stuff inside of him? It stays. Okay, so you did the squared, you did the tangent, who's next? You did the sine, and then who are you still missing? 4. So is there much you can do to that to simplify it? You could make it 8, right? 8 tangent of sine of 4x, secant squared of sine of 4x, cosine 4x, and that's it. I should be consistent. WebAssign would make you put parentheses here and here. Like, they're really picky about that stuff, which is a little bit, in my opinion, a little bit hypocritical because they don't always put parentheses themselves. So, but you just have to do it. Chain rule is not so bad once you learn how to understand it, right? Because it is pretty quick. You can just keep track of who you've done and keep multiplying by stuff, even when they're massively long chains. You see what I'm saying? Okay. Next one's implicit differentiation, right? Okay, so sine xy. First you differentiate. Sine, derivative is cosine. And then multiply by the derivative of xy, which requires the product rule. So what's x's derivative? 1 plus x times y prime or dy dx, who cares, whichever one you like better, equals minus dy dx. I think since there are dy dx's on both sides, it's best to distribute. Let's write that as y cosine of xy plus x cosine xy times dy dx equals 2x minus dy dx. Does that make sense? Okay, then what, if you put all the dy dx's on the left, what's your left side going to look like? X cosine xy dy dx, and then I couldn't hear what you say next, sorry. Plus dy dx equals 2x minus y cosine of xy. Great. Is that okay? Now when you factor out the dy dx, what's left behind? X cosine xy and a 1. The 1 is one thing that's often missed, but yes, you got that.
It's not favorite part.
Okay, and your final answer is dy dx equals 2x minus y cosine of xy over x cosine xy plus 1. There you go. Woo! All right, next. How about this one? So you have sine x plus cosine y is 1. Find the second derivative or second derivative in the other notation, but you have second derivative. So first you must find the first derivative. So what's the derivative of sine x going to be? How about cosine y? Negative sine of y times y prime. And don't forget that 1's derivative is 0. I've seen students make problems like this a lot harder by not having the constant's derivative go the right place. Just that's silly. So negative sine of y times y prime equals negative cosine x, or y prime is cosine x. Yep. And why can't you say cotangent? Not the same variable. Does that make sense? So you're stuck with that as your y prime.
Did you make it a crazy fraction, like cotangent of xy?
No, you can't.
Just
No, cotangent of xy, by definition, means cosine of xy over sine of xy. Like the things inside are the same. So nope, you can't. Okay, so to get the second derivative, what rule do you have to use? Quotient rule. You could use the product rule and the chain rule, but I'm just going to use the quotient rule. So y prime prime is
we avoid the quotient rule a lot.
low d high, which is minus high d low, which is cosine y times or y prime, but you know, whatever. Say that again? It is y prime because you took the derivative of y, which is y prime. Whereas, so Mary Kate, on the left side, you took the derivative of y prime, that's y double prime. Does that make sense? No, just because it's a second derivative doesn't mean it's a second derivative everywhere. All over sine squared y, right? The y prime should be negative? Say that, so you have, okay. So now we have y prime prime is negative, I'm just going to do alphabetical order, sine x, sine y, minus cosine x, cosine y, and the tricky thing here is actually put in what y prime is. You see what I'm saying? So y prime is equal to,
See, we forget that.
yeah, all over sine squared y, right? Right. Okay, so that's negative sine x sine y minus cosine squared x cosine y over sine y, all of that business over sine squared y. Is that okay? All right, now there is a clever thing that you can do to get rid of the denominator in the numerator. What is it? Multiply by sine y. If you multiply the numerator by sine y, you also multiply the denominator by sine y. You're multiplying by sine y over 1 and sine y over 1, right? Okay, so that makes the second derivative into negative sine x sine squared y minus cosine squared x cosine y I did it right? Yes, I did. Okay, over what?
Tan squared y.
I think it's sine cubed y. Is that, you buy that? Okay, and is there a greatest common factor in the numerator? Not really, or there's a negative, right? I set mine simplifying a little bit. No, it doesn't simplify, that's it. Okay, we're done. You could take the negative out if you wanted to, right? But whatever,
Yeah.
whatever. Okay. Now on to some applications. So find the points on the curve where the tangent line is horizontal. So what are you looking for in this case? If the tangent line is horizontal, derivative is equal to 0. So take the derivative, set it equal to 0. Do you guys get that for your derivative? Okay, take out the 6. All right, and how does that expression factor? So the x's that make this happen are great. Most of you took this question in your quiz, you got that much, like that was fine. The problem that you had was if I say to find the point on the curve, that means points implies ordered pairs. Like you need to give an x and y coordinate. And where do you plug them in? The derivative or in the original? In the original, because the derivative will tell you the slope. You plug those in, you're going to get 0, right? So the y would equal 2 times, well, 2 cubed is 8, minus 3 times 4, minus 12 times 2 plus 1. So was that 32 minus 12 minus 24 plus 1? I think that's 1. No, it's not. I lied.
16 minus 12?
No. Yes. I'm just teasing. Yes, it is. Okay. 16 minus 12. So that's minus 36. Negative 19?
Yeah.
Okay, so 1 is 2, negative 19. Hopefully I can do negative 1. So it's got to be negative 2 plus 3 plus 12 plus 1. Do you agree with that?
Sure.
Sure?
I agreed with you the first time.
No, I lied. 2 times 8 wasn't 32. What the heck? So y is equal to 14. Don't ever let a mathematician handle your money about big ideas and not specifics of adding correctly. It's probably not true for all of us. Like I know one of the people that we work with is really, really, really meticulous and good at this. That person is not me. My husband handles our money. I just say that again. Would not be negative 3. What happens when you oh man, yes it would be. Oh my gosh, look at, you shouldn't have trusted me, guys. That was negative 3.
Where?
Yeah, you just, how, what? Dishonor on you, dishonor on your cow. Okay, except for Mary Kate, who stood up to me. Okay.
This close to giving you my money too.
Yeah, right. Okay, so yeah, that should be negative 3 still. All right. So is this now, I hate to say, is it?
It's 8.
Okay, great. Thanks.
That makes more sense.
That makes more sense. Oh, yeah,
They
that
all
makes.
seem like arbitrary numbers anyways, I mean.
Well, it's, there are x and y coordinates on your curve. Like if you plotted that curve, you'd have horizontal tangents at those
It's
points.
just when I saw that curve in my head, it looked different, that's all.
I can't picture that curve in my head.
Exactly my point.
Oh. Okay, how about this curve? What rule are you gonna have to do to get the derivative of this dude? Or dudette? What rule on the sine squared?
Sine squared of x plus cosine squared of x equals 1?
But that's not cosine squared, that's cosine. Oh, how you wish. What's the derivative of sine squared x? So 2 sine x times cosine, right? That's the chain rule. Yes? What's cosine's derivative?
Negative sine.
Okay, great. So don't forget that differentiating sine squared involves the chain rule. Right, what next? When you're setting it to 0, you take out the GCF, which is? 2 cosine x minus 1. Okay. Now you're solving 0 equals sine of x, and 0 equals 2 cosine x minus 1. Okay, so is sine 0 at 0? Yes. Also at pi, plus or minus, right? Also at 2 pi, right?
Oh, yeah, forever.
Forever. So that would be x equals what with an n in it?
So,
With an n in it? Pi, yes. So what I would say, like sort of using the sort of pattern we've had, is it'd be 0 plus how far to the next one? Pi. How far to the next one? Pi. So 0 plus pi n or pi k. So that will just be,
the K thing means the same as an N.
the k and n mean the same thing. Like WebAssign, I think, made you use k sometimes. Did it use k? Yeah, k, but usually n is much more common for integer. I don't know why they made you use
Makes
n.
more sense.
I don't know.
Unless it's a integer.
Okay, this next one is the same thing as saying cosine x equals positive 1/2, right? By adding 1 and dividing by 2. Okay, in which quadrants is the cosine going to be positive? 1 and 4. So it's either this angle or it's that angle. It's the top one, it's pi over 3. So x is pi over 3, plus in this case 2 pi n. And then down here, you could express that one as either negative pi thirds or it would be 5 pi thirds. I don't care which one you use. And those can't be put together because those 2 points, you don't add a consistent thing to get from one to the other.
Yeah.
So. Okay. Oh, your face.
Yeah, did we get our Y points?
Oh.
Seems like a very odd thing to ask with this sort of question.
Well, it's actually not that bad.
I guess we
Well,
got those points, we know the X and Y.
but the x's are going to vary, but I don't think the y's are ever going to change. I don't think they're all 0. So for the x's being pi n, the y is going to equal, what is sine of pi anything? It's going to be 0. What is cosine? Oh, and that's going to be different for different ones. So, yep. I didn't intend for it to be quite that hard. In this case, I'm probably looking for the x-coordinates, but it's a good thing to point out. So if x is equal to pi times n, where n is even, okay? Does that make sense? If n is even, the y, which was equal to sine squared plus cosine squared, will be 0 plus, where are all the even pi's going to end up on the unit circle? Same right there, right? And so the cosine at that point is going to be 1. So the way to actually say that is to say 2 pi n comma 1. Because that 2 pi n keeps it even. So now what if n is odd? what is the cosine going to be in that case? It'll be like pi, 3 pi, 5 pi, 7 pi. That's going to put you over there, right?
Should be negative.
So it'd be -1. And the way that you have an expression that does all the odds, you say 2n plus 1 times pi. And then when you plug in any n, that keeps it odd. When you plug in 0, you get 1. You plug in 1 for n, you get 3. Okay, so that's a little bit complicated.
For this one, we'll probably just ask for X.
I'll ask for x's explicitly only, yeah.
And the second thing, we have basically the same thing, except we have.
Yeah, and the second thing is basically the same thing. So for this one, for that x, although I think this one, yeah, it's just going to be gross. Let's just not.
Do we?
No problem. Let's ask for the x. Yeah.
So good to know how to do.
Yeah, it's still good to know how to do. Okay, a particle moves along vertical lines with its coordinate at time t is given by y equals blah. So this particle is moving on a number line that goes up and down. So like, there's 1, 2, etc. There's -1. Okay, so first of all, find the velocity function. So v of t will equal y prime of t, which equals what? Yep. The acceleration function is the second derivative, which is going to be, great. I don't know why I just wrote 64. Sometimes my hand has a mind of its own. 6t. Okay. What would the units of the velocity function be? T's in second, Y's in meters. So velocity would be meters per second. What would the units of the acceleration function be? Meters per second squared. Okay. Meters per second. Yep, exactly. When will the velocity be 0? So you set 0 equal to, that was 3t squared minus 12, right? So technically, for this problem, you do get 2 t's at least initially, right? Does that make sense? You do find that if you just solve the velocity equals 0, you get t equals positive 2, t equals negative 2. Because I said t had to be positive, you just say t equals 2, right? Okay. And next is your favorite. Sketch that diagram. So before we do this, let me just put a diagram here. So we have 0, 2, 5. Okay. So suppose your particle began at 5 at start, went back to 2, and then that was at, say, time t equals 1 or something. And then it turned around and went forwards again to 10 at time t equals 3. How far did it go? What is the distance it traveled? Think, how many spaces did it march? Okay, how many spaces backwards from 2 to 5? From 5 to 2?
11.
So this is 3. And then how many from 2 to 10? 8. Total of 11. Okay? Now, so the important thing is where you start, where you turn around, and where you end. Does that make sense?
How do you know this space should go backwards? Where did that come from? Three. Where
The,
did 3 come from?
the 3, I made that problem up, okay? So that would have had to come from some equation. But let's do it for the problem we have, okay?
Oh, okay.
So for the problem we have, it technically goes up and down on a y-axis, but I just don't have space. I'm going to draw it horizontally.
That makes sense.
So how would you figure out where the particle starts? Not that hard. Set time to 0, as in plug 0 in. So when t is 0, what's the y equal to? 3. So there's 0, 1, 2, 3. So you're there at time 0. Okay. When you turn, the velocity is 0. Does that make sense?
Like,
That's,
You put that in the initial,
you put it in the original, yep, because the original equation tells you the position,
the start position.
the start position, or any position at any time, right?
Oh, yeah.
Yeah, but that tells you the start for sure. The turnaround point is when t is 2. And when t is 2, the y is equal to, what, 8 minus 24 plus 3. Do you guys buy that? I think that's negative 13. Do you agree? Yes, okay. Just nod before I go with it. So whatever, you go backwards to negative 13. So you start there. And then at that point in time, you turn around and you go forwards forever. Now let's figure out how far did this thing travel in, we'll say, the first, I don't know, 5 seconds. So what's my missing piece of information? I'm adding this in because you're going to have to do it in your test. Yeah, t equals 5. Your y would be 125 minus 12 times 5, whatever that is. Okay, plus 3. So 125 minus 60 would be 65, plus 3 gives you 68. Okay, so you're over here at 68 at time t equals 5. Okay, so figure out how far this thing traveled. So how far from the 3 to that negative 13?
16
Mm-hmm.
plus 68.
16 plus, okay, so you did this part.
Oh, do we,
You did this part. That's the 16, right?
no, it's 32.
And if you do 68, that adds on this part, right? So how much are you missing?
13.
Another 13. So 16 plus 68 plus 13 is whatever, 39 plus 68, right? Crap. Yes.
A little over 100.
97.
Right, so-
I added wrong again.
Oh,
I know, right? Just fail me now. 97 is correct. And I think this was measured in meters, right?
we can fail you?
Sure, why not? Okay. I already passed this class. Yeah, a long time ago. Okay. Do you understand how to do those little diagrams, though?
Yeah.
Like, it's really not that bad.
Diagram, like, if
Because-
I do that for a long time, I guess I can measure some thing to picture it, but what is its purpose?
Because it lets you visualize what's happening to the particle. Without the picture, you can't tell, like, if you did the position at 5 minus the position at 0, you couldn't tell that the particle, like, so for example, if you just said, okay, at 5, my particle's at 68, minus at 0, it's at 3, oh, it just went 65 spaces. It doesn't show you that there was this bit where it went out and back.
So it's picturing it digitally.
Well, but there's also could be physical situations. Could you break it into intervals? Sure. But I need to, yeah, show me what you mean later, okay? Not right now, but show me what you mean later. Oh, yay. Okay, related rates. Your favorites.
Those are my favorite kinds of rates.
The ones that are related, they're so much fun. Okay.
Do you have any
Now-
idea how hard it is to do math when the rates are unrelated?
Yeah, very hard. So one thing before I start, I was kind of shocked how many of you can't find the volume of a cube.
It's just a.
Okay, so, okay, you're like, oh, the volume of a prism is length, width, height. Great. If it's a cube, what are all the sides? The same, they're all the same. Sarcasm meant there, okay? I'm so sorry, I just can't help it. X makes x to the x cubed. Cubed. My God. Sorry, okay. Okay.
What is a square cube?
What if it was a square? What would the area of a square be?
I don't know.
X squared? Oh God, okay, so if there are 6 of them on your cube, what's the area of all those? Sorry, okay, wait, the sarcasm is done now. Just, I don't want to ever see that again. There'll be a cube on your test, you better all say the formula, the volume is x cubed, and I'm gonna otherwise I'm gonna die. And that'll be all your fault. Okay. So the volume of the sphere is increasing at 4 millimeters squared per second. How fast is the radius increasing when the diameter is 20? So I think it's really helpful to write down what you're given and write down what you want, just because I can at least give you credit for that, and it's good to know. So what are you given? dv over dt, yep. Yep, and I made a bit of a typo there. That should have said, since it's a volume, it should have said millimeters. That should say cubed. That's my typo. That's the downside to making your own notes. Okay, what do you want? At, ooh, and now, yeah, diameter is 20, so r equals 10. And just for kicks, what will its units be? Per same time units as the other one, per second, because a radius is a one-dimensional thing. Yes. Oh, thank you, I missed the second M. Okay, great. All right, now you need to get the equation to relate the stuffs together. So you care about the volume and the, well, radius. So volume of a sphere, I'm not going to make you memorize this one, but it'd be helpful to know. Cubed. 3-dimensional things will have 3 variables in them somehow, just like the cube did. Okay, so now take your derivative. dv dt is 4/3 pi times 3. There we go. And once you get that, it's just like plug and chug, right? Identify rates, get an equation, take the derivative, plug stuff in. That's really all it is. The hardest thing is getting the equation.
Yeah.
And then it's, so maybe you're given one, and often the one you got to create your own is either Pythagorean theorem or trigonometry. So dv dt, what's going to go in for that? 4. I'm going to say 4 pi times 100. Yep. How did he get 100, guys? He did 10 squared. And also the 3's canceled. Yep. So dr dt is going to be 4. You can cancel 4's, sure. So what's dr dt going to be? 1 over 100 pi. Great. And then just make sure its units are going to be millimeters per second.
That's megameters.
Is that actually a thing?
Kilometers, megameters, gigameters.
Okay.
You get astronomical units in it.
I guess it's been a long time since I did anything astronomical. No, because the question said how fast is the radius increasing. Although, if it had asked how fast the diameter is increasing, it would just be that answer times 2. Because when the diameter increases, it increases on 2 sides. So it's a little bit of the radius on one side plus a little bit of radius on the other side. Does that make sense? Okay. Exactly. Yep. If you were asked for the rate of change of the diameter, it'd be 1 over 50 pi. Yep. Okay. Paper cups. Paper cup has the shape of a cone with a height 10 centimeters and radius 3 at the top. And for some reason you're pouring water instead of snow cone mix in your paper cone. I don't know why. So this is
Sometimes those are the cups they use for the little water things.
just terrible because you can't set them down. It's horrible. 10,
Job site.
3,
Upholstery.
I know.
Down.
Okay, and then you have your R and you have your H.
Remind me what the cone formula was.
The cone formula is, anybody remember? Uh-huh. Almost, pi r squared h.
doesn't always come out to what, pi 3/2, something like that?
Doesn't always.
Oh.
Yep, nope. So there's a reason that those dimensions are actually different variables, because they do both matter. We'll be able to use similar triangles to change it in this case. It's just that it's different in every situation. Okay, so water is poured into the cup at a rate of 2 centimeters cubed per second. So what rate are we given? We're given dV dt. Because you can tell the units are a hint, right? Volume cubic. What do you want? Yep. When, and its units are gonna be, will be centimeters per second, right? Yeah, they're in the problem. Okay. So now the problem is, if you're going to differentiate this, right now you have to use the product rule, and that could be avoided if you're clever. So it's really common in this case that you use similar triangles to figure out what the R and the H are. Do you see the relationship that you're going to have? 3/10 equals R over H. That's just basic geometry, right? And you want H's in your equation because you want to know dH dt. So we're going to say R is equal to 3/10 H. So V is now pi thirds times 3/10 H squared times H. And before you go on taking derivatives, simplify that little guy. What's the power on the H? H to the third. Okay, there'll be a 3 pi, what's the denominator? No. 100, there we go. Because you square the 3 and the 10, right? 3 squared is 9, but the 9 over the 3 is still just 3, right? And then the 10 squared is 100. Isn't that easier to take the derivative of than everything with the product rule? Yay, derivative of that. dV dt equals, what's 3 pi times 3? Time? 9, yay! 9 pi over, you look like you're like, oh my gosh, you destroyed all math and now everything is different. 3 times 3 must not be 9 anymore.
We put the pi over 3 and I was like, my mind exploded.
Put the,
When you did an easy step, you put pi over 3. I don't know why, but that made my brain stop.
oh, I see. Multiplying the 1 and the pi made you scared.
Yeah.
Yes, that's okay. Is everyone okay with what I did there? As in, I just took the derivative, right? Now can you plug your stuff in? What goes in for dV dt, if anything? 2. What goes in for H? 5. So can I just say 25 right away? Can you simplify it all before, yeah, 25 over 100 is going to reduce to, 9 pi over 4, right? So therefore dH dt is, great, 8 over 9 pi centimeters per second. I know. I believe this one was on that packet that I gave you. I ran out of examples, I did so many. So a balloon is rising at a constant speed of 5 feet per second. A boy is biking along a straight path at a speed of 15 feet per second. When he passes under the balloon, it's 45 feet above him. How fast is the distance between the boy and the balloon increasing 3 seconds later? Okay, so you have your balloon that's going up. Yay up. And then you have a kid on a bicycle who went past. Ish. Okay. So I'm going to call that x. You know that the balloon was, well, we can call this whole distance y. When they say distance, they mean straight line. So that's the z. Is that okay? So what are you given? Dy dt is, you're given something else, I think. Of the kid?
Yeah.
Yep, so that's, and you want d z dt when t equals 3 seconds, right? Do you buy that? And dz dt is also going to be in feet per second, right? Is that okay? So this question asks nothing about angles, so don't go using a trigonometric function, that'd be silly. So what equation relates x, y, and z together? Yep, x squared plus y squared equals z squared. Is that okay? Take the derivatives, 2x dx dt plus 2y dy dt equals 2z dz dt. And do the 2's matter? No, so let's just get rid of them. X dx dt plus y dy dt equals z dz dt. Okay. This one's a little bit more tricky because they don't tell you what x, y, and z are explicitly. You got to figure it out. So at t equals 3 seconds, how far has the boy gone? How far has he traveled?
15.
He goes 15 feet every second. He went for 3 of them.
45.
So the boy's gone 45 feet, okay? The balloon, how far has it gone? 15 feet plus, it was plus a 45 because when he went under it, it was already 45 feet above him. Does that make sense? So that's going to be 60, right? It's this additional height gain plus the height it already had, right? I think this problem even works out nicely that 45 squared plus 60 squared equals z squared. Devin, did you get a z for that already?
The 75.
Thank you. Okay, so you had to use the fact that you had to multiply distance, rate times time equals distance, right? Okay, but now that you know all of these things, this is your x, right? The 60 is your y. And the 75 is your z. You can plug it all in and find dz dt, can't you? Okay.
Was this a 3, 4, 5 triangle?
No. Well, maybe. As in, is it a 30, 60, 90? I don't think so, because that relationship has radicals in it. As in, like, I think keep them proportional, you'd have to have a radical someplace.
I'm just wondering, because 45 times 50, 15 times 3 is 45, 15 times 4
Yeah,
is 60.
that's, I'm afraid I don't know, I'm not, I plead the fifth, I'm not certain. Okay? Yeah, so it's possible, but I don't know. So 45 times dx dt, which is 15, plus 60 times dy dt, which is 5, equals 75 times dz dt. Okay, what's...
Final answer is 13.
So what's the numerator? Something plus 300. 625? 675. And I think it is 13. I remember this problem, 13. feet per second. I believe the next one was also on your packet. The angle of elevation of the sun is decreasing at a rate of 0.25 radians per hour. How fast is the shadow cast by this building increasing when the angle of elevation is pi 6? Okay, so you have your building. And you have this sort of triangle, like the sun's up here. And this angle right there is the angle of elevation of the sun. This is only true to a certain point, like, once that sun sinks too far, it'll be completely behind the building, and, then it's kind of game over. But we're assuming we're not to that point yet. Which sides in this triangle are constant? And is that the vertical or horizontal side? Vertical. And the horizontal side is the shadow, right? Call it X. Okay, so what are you given? D theta dt. Okay, and what do you want? And it is, yes, sorry, it is negative. Yep, you do have to incorporate that because it is going down. Does that make sense? The angle is getting smaller. You want dx dt when theta equals pi over 6. Okay. Now you have two options. Okay. Option 1. Is it pretty obvious you're either going to use tangent or cotangent? Yeah. There's no reason to use sine or cosine if you have the opposite and adjacent sides. That's silly. Don't do that. So option 1, you can use tan theta equals 400 over x. Option 2, you can use cotangent theta equals what? X over 400. Option 2 is better, and I'd like to tell you why, okay? With option 1, take the derivative. You get secant squared theta d theta dt equals 400 times negative 1 x to the negative 2 dx dt. What's the derivative for option 2? D theta dt equals 1 over 400. Yep. Okay, so for option 1, it is possible when you know this theta's pi 6, you can figure out what x is. Right? You could say tangent of theta equals tangent of pi 6 is 400 over x. You could solve for x. That'd be fine, okay? But in this one, you don't even have to know what x is. As long as you do it correctly, you're going to get the same answer. But I've never seen anybody do option 1 correctly because they get lost in the details. Okay? The example we did in class like this, we knew the side that was the base, and we wanted to know how the other height was changing, in which case it made sense to use tangent because you had x over number, as opposed to number over x. Okay. So using that, so cosecant is 1 over, so we're going to go with option 2. Cosecant is 1 over which function? 1 over sine, yep. Oh, can I just say 400 over? Does that make sense? Because I just multiplied the 1 over 400 to the other side. Okay, so dx dt will be negative 400 sine squared of pi 6 times d theta dt, which was negative 0.25 or negative 1/4, right? By that. So what's the 400 over 4 going to make? 100. Okay. And pi 6. Yeah, so at pi 6, the sine is 1/2, right? Do you buy that? So that's how far up the coordinates there are. Root 3 over 2, 1/2. So the sine is the half. So over 1/2 squared. So that's 100 over 1/4. If you had $100 in quarters, how many quarters are you going to have? 400. I think it's because it's in feet per hour. Because the fact that the time units are kind of large is why this is kind of large. Does that make sense? If it were feet per minute, it would be this over 60, right? Okay. If you can find a way to make x be in the numerator, that will be the easier option. Does that make sense? Does that make sense? Yeah. And you also only need to use a trig function if you're asked about something involving an angle. So like there was the other triangle that we had that didn't involve anything about an angle, right? So yeah, you only use this if you have something that says, okay, this angle is decreasing, something is rotating, then you also use angles because angles describe rotations. So how about this one? This one, mostly the things that are getting are the semantics. A plane flies horizontally at an altitude of 1 mile and a speed of 500 miles per hour. So the plane is not ascending or descending, it's 1 mile up. And it's buzzing along. Okay. And it goes over this radar station. Looks like a light. All right. So call this X, call this Z. So what are we given? We're given dx dt is equal to 500 miles per hour. What do we want? You want dz dt. And here's the tricky thing. When, okay, if you're measuring the distance from the airplane to the station, which part of the triangle is this? Z. If I want, so the most common mistake on the quiz is people plug that in for X instead. Now, here's what I had to say to make that happen. I would have said, when the plane has flown 2 miles, how fast is this distance increasing? I didn't say that. I said, think like this is how far the signal's traveling from that station to that plane, right? Does that make sense? The signal doesn't go up and over, it just goes straight, right? Okay, so that was the tricky thing. You had to put this in the right part of the triangle. After that, it's just Pythagorean theorem. Now for this one, it's okay to plug in 1 right away because that 1 is always constant. It's always 1 no matter what. As opposed to Z, which is 2 at a specific instant only. So what, you could also have said, like, if that was a Y, you could have said dy dt was 0. Yep, that would also be fine. So 2x dx dt plus 0 equals 2z dz dt. And then kill off the 2's. So x dx dt equals z dz dt. Oh, and I guess we don't know x. So we know z is 2. So 1 squared plus x squared equals 2 squared. So x is equal to, x squared is 3, x is root 3. So root 3 times 500 equals 2 dz dt. And therefore dz dt is 250 root 3. Miles per hour, yep. You could say mph, just means the same thing. Okay. All right, and then the last is this linearization business and differentials. So we didn't have a quiz on this, but there'll be something on your test about it. So just count on that. But nothing will involve a calculator. So find the linearization of this function at a equals 4 and use it to estimate root 4.1. So the linearization just means to find the what? So find the tangent line at a equals 4. So you're going to also need the y coordinate at that point, right? So what's f of a going to be then? 2. So we're the point 4, comma 2. Okay, so then to find the tangent line, what do you need? You've got the point, you need the slope, for which you use the derivative. So f prime of x is 1/2 x to the negative 1/2. So your slope is 1/2 root 4, or a quarter, right? Okay, so y minus y1 is m times x minus x1. So y minus 2 equals a quarter x minus 4. And in this case, you do have to actually solve for y. So y minus 2 is 1/4 x minus 1, where y is 1/4 x minus plus 1, right? Does that make sense? Okay. So how do you use this to estimate root 4.1? So this linearization approximates root x for values near 4, right? 4.1 is pretty close to 4, isn't it? So root 4.1 is going to be about equal to plugging in 4.1 in this equation. So 1/4 times 4.1 plus 1. And I'll be the first to admit that I suck at arithmetic, but I'm not going to give you a calculator, because how could you take a quarter of 4.1? What would be your strategy? Can you do a fraction? Okay, that would work, sure. You could do that too. You could do both. I was thinking divide by half twice, like divide by 2 twice. That was my strategy. But if you make it into a fraction, so that's 4 and 1/10 is the same thing as 41/10. So that's going to be 41/40, right?
So call 1 40/40, and you get 81/40.
Yeah, exactly. So 81/40. Sure, that works. If you did divide by 2 twice, you would have half of 4.1 is 2.05, right? Does that make sense? And then half of 2.05 is going to be what? 1.025. And so you could have also said this is the same thing as 2.025, right? And that should make sense that it's awfully close to 2, because 4.1 is awfully close to 4, right? Okay.
I think it's better to leave it at root 4.1.
You totally missed the point of the problem then. But okay, sure. All right. And And then I think this application of differentials is pretty neat. So the radius of a circular disc is 24 centimeters with a maximum error in measurement of 0.2 centimeters. Use differentials to estimate the maximum error in the calculated area of the disc. So the area of a disc is pi r squared. And there's no t in this equation, so you don't find dA dt, you find dA dr. Remember that? So what's the differential of a equals pi r squared? That was dA. Technically over dr equals 2 pi r, right? But then we move that dr over. So we said dA equals 2 pi r dr, and that thing is the differential. Just be careful in WebAssembly, you have to have that little dr or ds or d whatever there. I don't know if it gives it to you in the like a box you put your answer in, I can't remember, or if you have to actually put it in yourself. Okay. So you measured the radius as 24 centimeters, so you say you found r is 24. The error in your measurement was 0.2. So what does that correspond to here? dr, yep. So dA would be an estimate of what is the change in the area if you're off by that much. So there'll be 2 pi times 24 times 0.2. So what's that going to be? 48 times 0.2 will be, I got 9.6. Do you buy that? 9.6 pi. 48 times 0.2 is 96 decimal over one spot, right?
We wouldn't have to.
There'd be no, I would make you multiply the real number, like the whole numbers together, but you can't do the pi thing, right? You just leave it as pi, if it was a no calculator question. Okay, and what would its units be? If it's a change in the area, or an error, so it'd be centimeters to the squared. So if your radius is off by 0.2 centimeters, your area is off by 9.6 pi, which is approximately 30. Does that make sense? Because 9.6 is about 10 and pi is about 3. It's like if you want to get a rough estimate of how big is that, it's about 30 square centimeters. That would be like the worst case scenario. Okay. Now what has a bit more meaning is that how much is that relative to the whole thing, right? So the relative error is this dA over A. It's like your error relative to the area found using that 24. So that's going to be 9.6 pi over pi r squared, so 24 squared pi, or 9.6 over 24 squared, which is about equal to 0.0167. I'd either give you super nice numbers to work with or just have you like leave it as a fraction. The pi's cancel, right? Okay, so what is that as a percent error?
6, 7.
Mm-hmm.